The absolute value function looks like this. It's defined to be the absolute value of x is what's called a piecewise function. It's actually a function that's determined for 3 different values of x. It looks like this. If x is, it's going to be just x if x is bigger than 0.
What is this scribble?
What's that big
That means I'm going to define this one function actually going to be 3 functions that are pieced together. Okay, so this is like an open bracket or something. Okay? It's going to be just x if x is bigger than 0. It's going to be 0 if x equals 0. And it's going to be negative x if x is less than 0, or the opposite of x. This is called a piecewise function. It's a function that's defined, it's actually 3 different functions smushed together. The absolute value of x is defined mathematically to be this number x if x is bigger than 0, 0 if x is 0, or the opposite of x if x is less than 0. And if you piece these 3 functions together, you end up with this graph. You end up with the line y equals x if x is bigger than 0. You get the point 0 if x is 0. And you get the line y is negative x, or a line with slope negative 1 if it's less than 0. So what that ends up giving us is that y's are always bigger than 0. Whenever any x we plug in, we always get a y that's bigger than 0. And its graph is this kind of V shape. Anything that's less than 0, y is positive, and then it bounces back up and becomes positive if x is now becomes positive. Okay? What we can do is if we know what the graph of y equals the absolute value of x is, then we should be able to figure out what the graph of, say, y is the absolute value of x plus 3. If we add or subtract outside of our grouping symbol or outside of the absolute value symbol, that's going to shift our graph vertically in this fashion. Okay? This is going to apply, adding or subtracting outside is going to apply a vertical shift. So what's going to happen? What should this graph look like compared to the original? Nate?
I guess not higher up though. Just we're not steep.
This, we should end up with a graph that looks something like this. Again, because we're added outside, so we have a vertical shift. By 3. Before we go much farther, I'll throw out the general form of an absolute value. So here are all the different places we could adjust this formula by either adding or multiplying. We could say multiply by something outside of the absolute value symbol. You could add or subtract inside, or you could add or subtract outside. This is called the general form. Of an absolute value function. Because we could add, we could multiply to the group, we could add or subtract inside, or we could add or subtract outside. What's nice is that each of these different things has a different effect, has a specific effect on the graph. If we add or subtract outside, K is going to tell us vertical shifts or slides. So we'll slide or shift if we add to the outside up and down. We'll go left and right if we add things inside. So inside is going to be horizontal shift or slide. And notice this was plus, so we'll do the same. This was minus, so we'll go opposite of what's inside. A is going to be kind of what Nate was talking about at the beginning with this called a vertical stretch. So we'll stretch this thing, either pull it, stretch it closer together, or we'll shrink it and condense it and by effect widen it. So change, like, you can think of the slope of the lines. So a general form, this should be a shift left by 3. So instead of starting at 0, 0, we'll shift to the left 3, go 1, 2, 3.
So if it was minus 3, go to the right.
Opposite left and right of what's inside. So instead of going plus 3, which would be to the right, we'll go opposite of plus 3, because it's a minus h. Well, opposite of plus 3 is negative 3, or to the left 3. And it still has, the same general shape. A hasn't changed, the same general shape or same slope as before. So we still go up 1 over 1, and so forth. So it's the same general shape. Okay. Or in particular, if now instead of adding or subtracting, we'll multiply the outside. So this time, there's nothing added or subtracted, so there's no shifting. It's still going to start at the same spot the parent function did. We're still going to start or have our little vertex here at 0, 0. But this time, instead of having our slope, or think of it as slope, our lines, instead of going over 1 and up 1, say if we go to the right, now what's our line slope going to look like? Well, now it's be affected by negative 2. So if you think of switching this line that has slope of 1 to now a slope of a line that has negative 2, what's the slope of a line with negative 2 look like? Down. And down how much? Down 2 over 1. Down 4 over 2. And then it should be mirrored going the other way. So then we should be going, say, down 2 and back 2. Yes. After. Okay. This is vertically stretched. There's 2 L's in there. By 2. I've pulled it apart, so now it's going down. Now it's changing by 2 for every one. It's also been something else. Instead of coming up, it's now been flipped down. What's another word for flip? Reflected. Nice. This has also been reflected. So your last one is vertically shrunk by a factor of 1/3. All right, the descriptions I see. The descriptions first would be, bring it back inside here, people. The description of how this would change compared to the parent would be the following. We're subtracting 2 outside, so this is a vertical shift down 2. It's a horizontal shift left 3. And we've got a number multiplied to it, so this is a vertical either stretch or shrink. Since it's less than 1, this is a shrink. By a factor of 1/4. So doing that, I'll go down 2, left 3, and then I'll shrink this by a quarter. So I'll go up 1 and over 4. Up 1, back 4. And your graph should now look like so. So we'll plug in those, and we have a triangle shrub protector, so it should be connected something like this. What would be a good equation for this shrub protector? Now, it looks a lot like our absolute value, but what's happened to it? Has it been? How has the vertex been shifted? It's been slid up and down and left and right.
It's minus.
Okay. So in words, what's happened? It's gone to the right 5. So if we want to do a horizontal slide right by 5, is we need to have a 5 in here, and we're going to do the opposite of positive 5. It's been slid up 6, and vertical shift is the same. So it's been up 6. And now all we need to do is come up with, well, what should the slope of, say, the positive half of this be? So what's the slope of this?
6 over 5.
It's got a rise of, say, -6 and a run of +5. It'd be, think of slope of, say, the second half of this line. It goes down 6 and over 5. And that should make sense. A negative slope for sure. Negative slope for sure because it's a reflection. It's been flipped upside down, so the slope or this a value better be negative. Take the function and shrink it by 1/3 and reflect it. How is the second function going to change? What are the transformations going on in the second function? What's one transformation? Which direction, left or right? To the right one. So this is a slide. This should be a slide to the right one and slide what direction? And then there's another slide. Up by 3. So looking at the transformations, they're going to that same guideline, the general rules. There should be a slide right 1 and slide up by 3. So take each of these points and slide them right 1 and up 3. So this point gets transformed to this point. This point goes right 1 and up 3. And this point goes right 1 and up 3.